I'm going to demonstrate the brain, which is part of the Power Station platform. My name's Ken Jones. I'm joined by Mark Sunston and Eric Zylstra. The three of us designed and built the brain, which is a energy trader's prediction modeling system. Brain is an application of a larger platform that does a lot more than just predicting using machine learning. It does a lot more than that, but we're just focused for this conversation on the brain application, which is where a trader or an IT person that's working with trading desk could go and create their own prediction algorithms for LMP prices or weather observations or commodity prices like coal and natural gas. It has a lot of capabilities to extend far beyond that, even to stocks, options, other things. But right now we are highly focused on locational marginal prices for energy. And we are focused on this because traders need to be updated and receive alerts when watching particular locations. Let's say, for instance, in the Southwest Power Pool area, and they're watching certain locations and they're looking for spreads or predicted spreads between one location and another to potentially execute a profitable energy trade. So I'm going to show how this application works from the beginning. When I first go into the application, you can see there's one brain available in my dropdown, or two, but one right now. And each brain has outputs that you can select from, meaning a brain is a neural network, and the neural network can have many different outputs. The one I'm showing on the screen is for SPP ERCOT North total LMP price, but I could just as easily add outputs for congestion or marginal energy or marginal loss. All of those prices make up the total price for the LMP, the locational marginal price. So I'm looking at a previously created brain. I can click analyze and I can see statistics about this brain that was previously created. I can take the topology of the brain and I can rotate it to look at what does that neural network actually look like with inputs and outputs and the hidden nodes that are part of the neural network. I can also change the layout type, so change the topology graph so I can look at it at different angles, either 2D or 3D, and really examine the topology of the network. On the left, I have what we call point statistics, which are measures of the brain's ability to predict something that's going to happen, let's say an hour or 24 hours from now. So usually when I'm looking at point statistics, there's only a few that I'm really looking at. How many data points did I train it on? And in this case, you can see I trained it on 6,300 data points and did validation testing on 6,200 data points. Look at the mean error to see between testing and training. Is the model overfitting or underfitting? How does that look? The standard deviation and the 95% confidence band, which is 2 standard deviations. So I'm looking at those to see if I'm overfitting or underfitting the model. And I can change people call it the alpha, or some people call it the beta number that you can add into the ridge regression that's used so that it helps regularize your model and not put too much confidence in just a few parameters that would end up creating overfitting. Another thing I'm looking at is the trigger performance of the model. The trigger performance of the model is once you've made an output from your brain, let's say that predicts total LMP price for ERCOT North, in 24 hours from now, you're going to end up using that as an alert to alert you when the spread, for instance, between current ERCOT North price, the spread between that and the 24-hour prediction of the ERCOT North price exceeds, let's say, $10. If it exceeds $10, we want the brain to alert the trader that created the brain and set up the alert. And so the trigger performance is telling us that during its testing and validation, it got that directional change, the fact that it was going to go up by at least $10 when it triggered on that $10 level. It was correct 87% of the time during actual testing and validation. So that's a good measure. 85% and above is very good for alerting. In this particular case, if it was down by, let's say, the 55 or 60% range, we would say that model is pretty worthless to a trader because it's worse than randomly guessing it, whether something's going to go up or down. So that's what that measure is looking for, and that's what I'm looking for in when I'm doing analysis on the brain. So pretend I'm someone coming in to create a brain for the first time. I can come into the screen and click the create button, and I'm going to give the brain name a name. I'm going to name it Chase after my firstborn son. I'm going to put in a size, which is the number of hidden neurons in the neural network. I'm going to keep it small for right now. And I'm going to be trying to predict 1 hour in advance, just simple 1 hour in advance. I'm also going to click auto train, and I'm going to give it a beta, which I'm going to set it at 0.0 because I don't want any regularization in the first cut of my neural network. Now I have to choose inputs and outputs. So I'm going to choose something simple for purposes of demonstration. I'm going to choose the trading hub tag, which trading hubs are within SPP. They are the major the points of intertie into and out of Southwest Power Pool. So I'm just trying to take as inputs all of the LMP prices and marginal losses and marginal energy and congestion prices and feed them into the model. So I'll put them here as inputs, and then I'm going to only try and predict as outputs one of them, which is AECI. I'm going to predict for the output, I'm just going to do Southwest Power Pool AECI total LMP price. So now I have that there. This is a very simple model, so it should go quickly to actually set up and create. And I'm going to press submit. So now we get a message that the brain has started doing its creation process and training. And I will get a text alert several times when the brain has completed being set up. I will get a text alert. Then I'll get a text alert later when the brain has done its pre-training to prepare the values for the neural network training. Then I'll get a text alert as the brain is trained. And finally, I'll get a text alert when the outputs have been prepared and I can go analyze the model. That, in a nutshell, is everything I need to know, because now when that is completed, the new brain named Chase that I put in, named after my firstborn son, will be in the brain drop-down list, and I'll be able to go analyze it. And that, in a nutshell, is how we use the brain.